In this video, we're going to talk about percent growth and percent decay. In this example, you have money that you're depositing in a savings account, and you get 5% interest every year on the amount of money that's in the account. So let's say you start out with $400 in the account. We want to figure out, maybe after each year, for a few years, how much money we're going to have in the account at the end of the year. So first I have to figure out, if I'm making 5% on this, I have to figure out what the interest is. So I'll take that 5%, remember 5% as a decimal is 0.05, divide by 100 to take it out of the percent. And so when I multiply, I'm going to get $20 of interest. Now that's my interest, but I don't want to know just how much I have in interest. I want to know how much is in the account. So I have to take that 20 and I have to add 40 to it. So I have to add this and the original 400 to it rather. So that means I'm going to have $420 in the account after year one. Okay, well, now let's say I want to find out year two. So I'm going to take that 420 and I'm going to get 5% interest off that. So I'm going to take $420, figure out how much interest I have. So again, I'll multiply that by 0.05. That's going to give me my interest. And that gives me $21 of interest. Well, I don't want to just know my interest, so I have to add that to what I started with at the end of year one or the beginning of year two. So that means that I'm going to have $441 when I combine those dollars after year two. So as you can see, this is very tedious. If I wanted to find out, I don't know, after 10 years how much money I'm going to have in this account, I'm going to have to do this process 10 times. So there's got to be an easier way. So let's just explore this a little bit. Instead of multiplying by 0.05 and then adding it back, I could take my original amount and multiply it by 1.05. So in other words, for the first year, I could have done $400 and so we're looking for a better way. So I take that $400 and I can multiply by 1.05. And when I do that, I get 420 for the year. Okay, and then I could take that 420. So this is 1 year. Take that 420 and multiply it by 1.05 again. And that would give me 441, which is the second year. A little easier, but still kind of tedious. Just a quick explanation why this works. You're taking this times 1, which gives you the original amount, and then you're taking that times 0.05, which gives you the interest, and it combines it all together when you're multiplying by 1.05. It's like the distributive property. But still, there still has to be a better way. Let me just do one more year here. So if I continue this process, though we still think there's got to be a better way, well, that's the third year. If you notice, I'm doing something repeatedly. I'm multiplying that value by 1.05 every time. So if I wanted to know directly from the beginning, 400, to how much I'll have at the end of 3 years, I could have just done, okay, 400, I'll multiply that by 0.05 every year I want. So since I want 3 years, I'm going to do it 3 times. And this will give me my $463.05. But if I want to do this 10 times, who wants to write this 10 times? So we still get a better way. If I'm multiplying repeatedly by the same thing, I could use exponents to represent that. So technically, I could have just went, okay, 400, my original amount, is 1.05 times t, where this t is the number of years. And this all together will give me my amount, which I'll use A for. So if I wanted 5 years, I'd just put 5 in for t. If I wanted 10 years, I'd put 10 in for t. And that's just one simple calculation. What's happening here is it's constantly increasing. It's an exponential model. It's increasing. So increasing exponential model. And so the formula for this is Q of t equals Q naught. Those of you familiar with your science, that's Q naught, or subscript of 0, times 1 plus p to the t. So just to make note, this is the amount at time t, so whatever time you're looking for. This is the original amount, the starting part. This is when t is 0, before any time has passed what you start with. This is the percent increase. Remember that when it gives you as a percentage, you have to change it to decimal form by dividing by 100 first. Or putting it over 100 as a fraction will also work. And then this t right here, again, is time. So depending on the problem, it may be years, it may be, like in our problem prior to this was years, but it may be days, and it depends on the problem. And because you have a little plus here in the middle, this indicates that it's increasing. If this was negative, it would be decreasing. So here we have the same formula, but it's a negative. And so negative would be a decreasing. Exponential model.